Hello, GED students. Welcome to Math 144 Club. This is a mixed math review to prep you to get ready to take your GED test. And we are finally to our practice test. We've got all the different GED topics all mixed up. Obviously, we're not going to do everything today, but anything from the GED is fair game. So we are going to go ahead and get started here. We've got some GED students working with us today, and we're just going to do our best. We're going to use everything we've learned so far about algebra, about geometry, about points and lines, about data analysis and interpreting word problems to try to figure out what do I do on the GED? And we're especially going to focus on what do I do when I'm not sure what to do? All right, let's get going. Sorry, I liked this guy. Okay, guys, so first one, we are not going to use a calculator on this one. Without a calculator, simplify. Well, let's just start with our usual question. What are they asking me to do or to find?
Make it easier.
I love it. She's like, well, that's what simplify means in common English, right? And it's definitely related when we talk in math and we talk about simplify. But specifically, when we say simplify, anybody know what I mean?
Reduce?
Reducing is part of simplifying.
Making it to the smallest number you can make it.
I kind of like the way you just put it there, Alicia. So simplifying is when you obey the operation signs. So you can see I have two operation signs right here. I have a square root symbol and I have that fraction bar. Those signify two different operations, a square root and division. So to simplify is basically to do as much of those operations as I can without making it more complicated, as Alicia pointed out. So we're not going to give like ugly decimal answers. So that being said, I sometimes just call it perform the indicated operation. Do what the symbols tell you to do. Okay, so reducing is definitely a part Manal because there's a fraction bar, but that's not the only simplifying going on here. I also have a square root symbol. Wonderful. Where should we start?
Finding the square root of each number.
Yes, Amy, absolutely. One of the nice things about fractions is because we multiply and straight across the numerator and denominator of fraction, basically, we are able to do the same thing with square roots. So what Amy is realizing is that I can just square root the top and square root the bottom. Now, you don't have to write about that, but that's me mathematically saying what Amy just told me. So let's do that. What is the square root of the top? What is the square root of 144? 12. Lovely. Thank you, Stephen. And the square root of the bottom, a square root of 100. What number times itself equals 100?
10.
10. So thank you guys for square rooting and not halving. One of the most common errors students make when they see a square root symbol is to half the number instead of taking the square root. Okay, wonderful. And so many students are so excited. I remembered how to do square roots. The fraction didn't scare me. I'm done. And I agree that this expression is right, but it isn't done yet. Anybody else know what we still need to do?
You have to reduce it to the lowest term.
Absolutely. When you're simplifying, you don't necessarily need to get rid of fractions. We're just fine with fractions, but all final fractions should be reduced to lowest terms. And so, yes, 12 and 10 have a common factor that we could divide out of them. We could reduce this sucker. What do 12 and 10 have in common? They have a 2 in common. I'll divide it out of both of them. And that's what it means to reduce to lowest terms, is to divide out any common factors. 12 divided by 2 is 6, and 10 divided by 2 is 5. Okay, now I have a lot of students, especially those who struggled with fractions, who want to keep working here. They look at this and they say, oh, I'm not done simplifying. My third grade teacher taught me I have to convert this into a mixed number. They don't like the improper fraction with the top bigger than the bottom. You guys, converting to a mixed number is not part of simplification. It's not necessary. It's not needed. It's not that you'd be wrong. It's just it's not needed. 6/5 is a perfectly legit simplified answer. There's nothing wrong with it. Okay, improper fractions are just fine on the GED. Lovely. So if you need to look at something like this, this is from the Math 101 Crucial GED Basics. Obviously, this is a pretty challenging example of a perfect square problem, but you know, we're just looking at perfect squares and their roots here. We did a square root. Which of the following expressions could represent the distance between point C and E on the number line? All right, guys, what are they asking you to do or to find?
Distance between 2 points.
Wonderful. And they're not really just asking me to find the distance. They are asking me to, if you take a look at these, you can see It's not a number or an answer as we think of it. Those are expressions. So we're writing an expression to represent that distance between point C and point E. All right, not necessarily one right way to attack this. So what are you guys thinking?
The answer is C.
The answer is C. Manal, what do you like about C?
Because it's inside the, I don't know what it's called.
Absolute value bars. Are you talking about those straight up and down lines, Manal?
Yes, yes.
Yes, wonderful. I like that too. So anybody, why is Manal liking the absolute value bars when it comes to distance? Anybody know why when we think distance, we should think absolute value? Amy, I see you nodding. What are you thinking?
Yes, because I remember you like into our head.
Pounding it into your head because students forget it so often. Yeah. What do absolute value bars mean or do that makes them so important right here?
It makes them positive.
Absolutely. Absolute value makes your answer positive. And what Manal knows is that distance is always positive. I liked the bars there too as well, Manal. Anything else that attracted you to the answer C?
It had minus.
Absolutely. Distance is synonymous with the word difference. It is the positive answer when you subtract two numbers. Yes, I love this. What this expression says is subtract, and then whatever answer you get, make it positive. Nice job, and all that is the right answer. And most students would just get intimidated by it because the symbols look so weird. Because a lot of students who would be just fine when there was a number using their common sense, all of a sudden it's letters and they don't have that theoretical representation of what it means. So it's going to be super important that you realize that if I say distance or difference, so let's just put this in our notes. Yes, we can use a visual representation to figure out other ways to do it, which you and I have done before. But mathematically, the way you do it is subtract the two numbers, whatever they are, and then the answer you get, make it positive.
So I guess you just imagine it being a number, kind of like.
Yes, imagining it being any number, just picking random numbers can help you to understand it better. And sometimes I do that with my students who especially struggle with letters. I'm just like, pick a random number, let's plug it in and test our theory. Okay, so this again is from the Math 101 Crucial GED Basics unit on the crash course. That's unit 0. And the topic is Intro to Integers, Absolute Value, and Distance. And once again, this is as hard as this concept gets, but the GED does tend towards complex problems on the non-calculator section. Let's look at the next one. Last one without a calculator. Here we go. Compute the product without a calculator. Hey, look, it's like third grade. It's not complex for once. What shall I do?
We put the number under each other, but with the decimal.
Okay, so Manal wants me to line this up using that standard algorithm to multiply. And I am multiplying. And then when you say with the decimals, what do you mean? Are you talking about having the decimals line up? Is that what you're talking about, Manal?
It's like that. And the empty places, we put 0.
Oh, okay. So just an FYI, you can do that, but it's not necessary when you're multiplying. It's only necessary when you're adding and subtracting. Because when you're adding and subtracting, we have to add the same things, tenths with tenths, hundredths with hundredths. But when you're multiplying, everything multiplies by everything else anyway. So don't worry about lining it up, because if you add extra numbers, you're making your job harder. And you wouldn't be wrong, Manal, if you did it. You'd just have more lines with more zeros, more chances to make a mistake, but you'd get the same answer I get.
So where would the decimal go when you get the answer?
Great question. Great question. That's what we're going to talk about. But let's talk about it at the end. Okie dokie, because right now I call it decimal denial. We could just start multiplying. Okay, so let's do it. 4 times 5 is 20. Put the 0 in the ones place, carry that 2 into the tens place. 4 times 4, and I know you're like, that's not the tens place, Kate, it's a decimal. Yeah. Again, it's like I'm ignoring those decimal places while I multiply. So 4 times 4 is 16, plus 2 is 18, carry the 1. 4 times 0, of course, is 0, plus 1 is 1. And 4 times 2 is 8. And now I've passed out that first number, that 4. And as you know, when we go to multiply, we got to keep passing out, okay? But super duper important, every time you move over a place, you don't just move over a place up here, you move over a place in your answer. So I'm going to fill in that first guy with a 0. And here we go again. 2 times 5, carry the 1. 2 times 4 is 8, plus 1 is 9. 2 times 0 is 0. And 2 times 2 is 4. And now I passed out the 2. Okay, now I'm moving over 2 places, so I need to start with 2 zeros. And there we go. 7 times 5 is 35. 7 times 4 is 28, 29, 30, 31. Drop the 1, carry the 3. 7 times 0 is 0, plus 3 is 3, and 2 times 7 is 14. Okay, once I've done my multiplying, now what do I do?
Yeah, add.
We add. Beautiful. Yes, the standard multiplication algorithm lets us multiply in pieces, kind of like the distributive property, and then we add up our answers. So that one's easy to add, 10, 15. You guys should be checking my work because it's really embarrassing when you're a math teacher and you make errors in basic math.
So far, yours is coming out the way I got mine, so I'm watching.
Wonderful. Good. Watch me, Stephen. Okay, wonderful. I love what Alicia said. How am I supposed to know where to put the decimal? So, Alicia, I'm going to give you the standard math answer eventually, but before we do the standard math answer, I would just like you to use your common sense. I want you to look back at the original problem and let's use some estimation. So this number is not exactly 2, it's 2.045, but it's real close to 2. 2.045 is like just a little 4 cents over $2. Can we just call it 2? Let's estimate. And then how about the next number? The next number is about how much?
7.
7. Girl, what's 2 times 7?
14.
14. Look at my answer. Where do you think my decimal should go? Look, I got something about 14.
So easy.
Okay, so easy when you have common sense. But what our problem is that we don't have common sense. We memorize algorithms, and then we like lose our common sense. Now, okay, let's do the standard math answer though. How am I supposed to know where to put the decimal? Because there is a like rule that we teach you guys. Anybody know what it is?
We count the decimals.
You move it over how many places, the decimal.
Lovely. So Manal says we count the number of decimal places. So we're going to come back here at the right of the decimals, 1, 2, 3, 4, 5. And as Stephen said, we're going to take it and we're going to count in our problem and get that same number of decimal places, 1, 2, 3, 4, 5. Decimal places accumulate when you multiply. So I have a way to memorize, but that better check with common sense. Now this, if you had this on the GED, it might even be multiple choice. In which case, you could just use that lovely common sense of estimation. Save yourself some time. Because when you are anxious on a test and you are doing multi-digit multiplication, there are so many chances for error with multi-digit multiplication. Please make sure you have those common sense estimation skills in order to check your work. Okay, so technically this is eventually going to be in the non-calculator section of the crash course, which I don't have up. It's on my to-do list, as are a lot of things. But one day in the future, I'll have multiplying decimals up there. But for now, you guys, if I don't have it on the crash course, everybody and their mother has a multiplying decimals lesson. You can find it on Khan Academy, Math Antics. Math is fun. There's hundreds of sites that do basic math, okay? So don't be waiting for me to do it. Go find it from someone. Here we go. Evaluate the function for x is equal to 2.5. And I have this gross looking function. So many students see this and just lose their minds, guys. Let's find our way. What are they asking me to do or to find?
You just plug in for the x.
Yeah, no, you're right. I already know what the x value is. It ain't a mystery. Stop panicking at the sight of letters. Stephen says, hey, I know what x is. I might as well just plug in that value of x. Let's do it. Every time I see an x, I'm going to write that number, okay? So this was f of x. Now it's f of 2.5. And careful, guys, that doesn't mean 2.5 times f. That just means the value of the function when x is 2.5. Now I'll write negative 0.7. I'll plug in 2.5. Notice I do it with parentheses whenever I see an x. I won't lose any operations. I'll still have my square, I'll still have my plus and my 1.2. But every time I see an x, I'm going to substitute it out for that number 2.5. And then there you guys were freaking out at the sight of this problem. And I got to say, it ain't algebra anymore. This is just a long, ugly expression to simplify. And guess what? If this came up, it would be on the calculator section. So you can take this entire ugly, disgusting thing, plug it into your calculator. And I'm going to do that. You should do it too. Make sure you know how to use a TI for this.
This one without calculator, right?
What was that?
Without calculator.
Oh, this would be on the calculator section if you had it. So you may use a calculator.
Okay, I was doing without calculator.
You can do it without a calculator if you're hardcore and you're cool. But this is how I feel. There's so much to do on the GED and so much heavy lifting and heavy thinking to do. If I can use a calculator, I'm going to. You know, I'm going to save my brain power for the parts where I can't.
So make sure you use the negative key, not the minus key, and then 0.7. And we'll open up parentheses to times it by 2.5. Close those parentheses before you then push squared. And we're going to add 1.2. Again, that's times 2.5. Close those parentheses one more time, and then we'll subtract. This time we do use a minus. We're subtracting 3.45. General rule of thumb is when it's between two numbers, we'll use the minus sign, but when it's out in front, use the negative. Go ahead and press enter, and you can see we get that negative 4.825.
I messed up, probably due to calculation error.
When you plug this into your calculator, don't forget the negative sign there. I call negatives like the coin. They're like the coins in your pocket of math. Okay, they just fall out all over the place. Students just drop negatives like everywhere. So if you get a funky answer that you weren't expecting, watch out for dropped negatives.
Is there a way to just fix what you put in your calculator?
Absolutely, there sure is. You could have arrowed up to the line that had the mistake in it. Press enter to get it back, and then just arrow over to where you want, and you can either delete or insert. It's the same button to delete, or if you press second before it, it's an insert button to change the calculation a little bit so you don't have to retype the whole thing. Yep.
That's amazing. Thank you.
I know. It is a good calculator, but it is not intuitive. You have to learn how to use it, get familiar with it. So this is from the algebra unit, and the topic here is evaluating algebraic expressions. This is not technically an expression. It is an equation. You know, it has an equal sign. But as we know, all an equation is two equivalent expressions. And once we plug that number in there, all we were doing was crunching numbers with that expression. So it's definitely a related concept, even though it's a challenging version of it. Okay. The Johnsons have an above-ground swimming pool with a diameter of 15 feet. They fill the pool 5 feet deep. If there are about 7.5 gallons in a cubic foot, how many gallons of water will it take to fill the pool? What are they asking me to do or to find?
How many gallons of water do you need to fill the pool?
That's our question. We're to figure out how many gallons of water will it take to fill the pool. Any thoughts?
I think you times a number by a number.
There's definitely multiplication going on, but just to let you know, this is something you can use the formula sheet for. I'm going to say that again. This is something you can use the formula sheet for. Basically, all our 2-dimensional and 3-dimensional measurements are on the formula sheet. So that will help us know exactly what multiplies if we can find the right formula. What formula should I use?
You have to find the volume, right?
Volume. What in this problem made you think volume, Manal?
Because there's a cubic.
One great clue is that we're looking at a cubic measurement. When you talk cubic feet or cubic yards or cubic meters or cubic inches, cubic centimeters, any of that, that is a 3-dimensional measurement. That is volume. Beautiful. Not the only clue in this word problem that was volume. Does anybody else see anything else that could help me to know that this was a volume problem?
Gallons?
Gallons. Gallon is a volume measurement, how much it fills. Absolutely. That's another clue. Not even the one I was thinking of. Yes. How about you, Stephen? What were you thinking?
I saw fill.
Absolutely. That's the one I was looking at too. When you're filling a 3-dimensional shape, you're talking about volume. So lots of clues here that this is a volume problem, even though they didn't come out and say it. Look at us using our interpretation of word problem skills. Beautiful. So volume, but volume of what? Once again, they're being big jerks, just like the GED, and not telling us the name of the shape. So any thoughts? Volume of what?
Rectangle prism.
Rectangular prism. Okay, what do you guys think about Manal's thought about this being a rectangular prism? Rectangular prism, by the way, is like a box.
I was thinking cylinder.
You were thinking cylinder. Yeah, pools can be either one of these shapes. And that's hard because that's going to vary depending on where you live. So is there any clue in this word problem that can tell me which one is the right one of these two? Because I've seen rectangular pools and I've seen cylindrical pools.
Because it said above ground, so that's why I was thinking.
Lucky Amy has a cultural reference. At least in the United States, the above ground pools are usually cylindrical. But poor Manal, she doesn't live where we live. What if they don't have cylindrical pools? Is there a word clue in this word problem that could tell us that it's a cylinder? I see one. I see one. There is a word clue in here.
Diameter?
Diameter. Bingo. See how I had the word diameter in there, Manal? It's only circular things that we talk about diameter or radius on. So it had to be something with a circle going on. And by the way, one of the big arguments against standardized tests is that they're very culturally biased, which obviously this problem was. If we are in a place where there's lots of above ground swimming pools, we're cool. But if not, we're in a little bit of trouble. We don't have a visual image to go by. There we go. Yes, we are going to find volume of a cylinder. So hit up the formula sheet. Hook it up, guys. What formula shall I use?
Volume V equal pi r square h height.
Beautiful. And Alicia, you can see some multiplication in there. We see 3 dimensions getting multiplied. The height, the 2 radius, and then that extra thing that we needed the formula for, pi. Anytime a circle gets involved, there's going to be a pi somewhere, which is why it's important to understand that formula sheet if you don't have all your formulas memorized. Now, as usual, when we use a formula, we should now do substitution. What do we know? What can we put into this formula?
Pi is 3.14.
Okay, Stephen says pi is 3.14. I know that.
The diameter is 7.5. The radius.
The radius. Okay. So let's talk about that because we don't have the thing we need. They told us that the diameter of this pool is 15 feet. But as Manal's pointing out, the formula has a radius. So how did you get using that diameter of 15 to 7.5, Manal?
I divided by 2.
Manal knows that a radius is half of a diameter. So she took that 15-foot diameter, divided it into, and found out the radius was just 7.5. Wonderful. So we'll plug 7.5 in for R. And of course, the formula says that R is going to be squared. Okay, what else do we know?
The height is 5, since it's 5 feet deep.
Beautiful. It's 5 feet deep. So we're talking the height of that cylinder. Gorgeous. Lovely. So that's what we know. Now what?
You just multiply everything.
Beautiful. We're going to do that simplifying there on the right-hand side. So 3.14 times 7.5 squared times 5. And again, I'm just typing it all on my calculator because I'm so lazy. Okay, so I got a lot of students so proud of themselves. They did all that hard work. They figured out it was a cylinder. They figured out it was volume, and they just stopped right here. 883 gallons. Yay! I'm so good at math. This is 883 what, guys?
Cubic feet.
Cubic feet. I just multiplied feet by feet by feet, those 2 radius and the height. Feet by feet by feet. I'm looking at cubic feet. And the question does not say how many cubic feet of water. It says how many gallons of water. Dang it, I am not done. Any thoughts?
Did you divide?
I love that you're kind of hesitant right there because that's the question now the students have, right? They're like, every time I'm converting, I know I multiply or divide, but I'm never sure when to do what. Should I multiply or should I divide? So let's think about this. It says that there are 7.5 gallons in a cubic foot. I have 883 cubic feet. So let's just imagine this is the first cubic foot, this is the second cubic foot, this is the third cubic foot, and so on and so forth. And then each one of these has 7.5 gallons in it. So there's the first 7.5 gallons and the second 7.5 gallons and the third one. In fact, we are going to have 7.5 gallons 883 times.
Okay, so when you put it in like a sentence and you say times, that makes sense.
Yeah, that's why I put it that way. But it's really hard for students to know whether to multiply or divide. And sometimes it's multiply and sometimes divide, depending on which direction you're going. Sometimes drawing out yourself a little diagram can help. So I got that. I'm going to do 883.125 times what? The 7.5 gallons in a cubic foot. And we're going to end up with a whole lot of gallons to fill that pool, which should make sense, actually. To fill a pool, it should be a lot of gallons. Okay, so I just want to entertain your idea, Amy, because you're going to be taking your test. Yeah, sure, you can draw diagrams, but you're going to be a little flustered. Everybody's a little nervous when they take their math test, right? I want you to imagine that you just did it the wrong way. You just said, you know what? I don't remember which one. And you tried dividing 883.125, and then you divided it by 7.5. And then you said it takes 100 gallons to fill the pool. I want you to imagine you took a milk jug 100 times to the pool. How much of a dent are you going to make in the pool?
Yeah, you a foot.
Don't be scared of going the wrong direction. Do be scared
Okay.
of your answers not making sense to you. So if you get that answer, you go, oh, it doesn't make sense. You probably use the inverse operation. You use multiply when you should use divide, or divide when you should use multiply. So use that common sense to evaluate your answers, because like I said, if you just treat math like a bunch of things to memorize, you're going to mix up all your steps and do screwy crap.
This one was a kind of a tricky one in a way.
Yeah, I put 2 tricks in there. Well, first of all, 3 tricks, I guess, because first of all, you've got to be able to even just read this and know that you're talking volume of a cylinder. That was hard enough on its own, right? So we already had that. And as Alicia pointed out, we have to know that we can find that on the formula sheet, or we'd be in trouble because we don't have memorized volume of a cylinder. You know, so that's one thing. And of course, second thing, I didn't give you what you needed. You needed radius, I gave you diameter. What a jerk. And then third thing, we weren't done with the formula. We had an extra conversion they slipped in the problem where they wanted us to convert between gallons and cubic feet. So yeah, there was a lot going on in this problem. It had a lot of levels of difficulty, and you can see why I would call this a GED style problem. It's because of problems like this that students will come to me and say, I felt like I did so good on my GED. And then I see their score and they got like a 139. And I know if you got a 139, you know, you got 2 out of 3 problems wrong. It means you got tricked again and again and again. Probably stuff like this, you know, just little stuff. Okay, so this is from geometry. The topic is surface area and volume. But once again, as we pointed out, there's a lot more than just understanding surface area and volume going on in this problem. Okay, I hope this is easier. It's got to be easier, right? Here we go. Approximately how many times as much rain falls in Connecticut in autumn as falls in California in the autumn? What are they asking me to do or to find?
To see how many times as much rain falls compared to Connecticut and California.
Wonderful. Okay, so we're comparing those 2 numbers, the rainfall in Connecticut in autumn to the rainfall in California in autumn. But as Amy pointed out, the comparison we're doing is how many times as much, how many times as much. Beautiful. Okay, so let's go find those numbers we're supposed to be comparing. Any thoughts?
We just need to focus on the autumn information.
Beautiful, I love that. It's as important on the GED to know where not to look as it is to know where to look. Gorgeous. So just autumn, okay.
And then just Connecticut and California.
Okay, so where's Connecticut?
So Connecticut is gray. And
How'd you figure that out, Amy? Humor me. Where'd you figure out Connecticut is gray? Beautiful, the key. Gorgeous. Okay, so Connecticut is gray and?
California is orange.
California is orange. Beautiful. So I'm comparing those 2 and I'm asking how many times as much. Any thoughts?
Well, you have to figure out, like on the gray one, it says is approximately what, 110? And then on the orange, you kind of have to estimate, I guess.
Is it 35?
Yeah, about 35. It looks to be in the middle of 30 and 40. If you can see, this is 40 and this is 30. It's somewhere in the middle. So I'd say it's about 35. And you can see the wording here. They're going to give you some leeway. Approximately how many times? Okay, so I got my 2 numbers. I have 35 and 110.
So it's saying times. So you basically have to, I guess, multiply the 35.
I love what you just said, Stephen, because Stephen's first instinct was to subtract. I heard him say subtract at first, but then as he started looking at this problem, he reevaluated. And that's what a lot of students would do at first as well. Usually when we're comparing 2 numbers, we subtract. But here we didn't say how much more, we said how many times more. So yeah, Stephen's right, we won't be subtracting. Instead, we're asking ourselves 35 times about what is equal to 110. Okay, any thoughts?
I came up with 3.
So Stephen says about 3. So what did you do? Just guess and check, like 35 times 3?
Yeah, and I know I can't go. If I go 4, it's going to go over.
So he said 35 times 3 is 105. And if I did 35 times 4, it'd be like way above. We're looking at 140. That's way too large. So the times 3 looks like a better answer. That's brilliant.
I did 110 divided by 35 and
Bing.
I got 314. So then I did 35 times 3.14 and that's how I got it.
Beautiful. So I love it. So Alicia knows that the opposite of multiplying is dividing. You can say 35 times what, or you can flip the problem on its head and divide instead. 110 divided by 35, yeah, gives us something really close. Beautiful.
What did she do? So she did 110 divided by 35.
Divided by 35 to figure out the other side of it. I don't know if they did it back when we were in school, but nowadays with students, they'll make these multiplication cards. It'll say something like this, 7, 4, and 28 on triangles. So students can see the inverses, relationships. So basically, if I cover up the 28 here, like cover this up with my thumb, 7 times 4 is 28. But if you flip that fact around, that's the same as knowing that 28 divided by 4 is 7.
Oh.
Or that 28 divided by 7 is 4. We have this relationship between these three numbers. And you know, if we go forwards, we're multiplying, but if we work backwards, we're dividing. And it's the same basic relationship between the three numbers. Does that make sense?
Yes.
Yes.
It's really nice. And if you understand multiplication and division or inverses, you'll be more successful in algebra, because algebra is the power to move both forwards and backwards, right? To simplify, obey the symbols, and to solve, disobey the symbols, work backwards. So that's very much algebraic reasoning on your part, Alicia, to say, oh, I could just divide. I love how we thought about this really different ways, and yet we all got to the same place. And that is just so typical of math. You know, there's more than one right way to reason this out. Any math teacher who tells you if you're not doing it her way, you're wrong, doesn't understand math. Okay.
That's how I was taught, and that's why I run into problems all my life.
Yeah, no, as long as you're good using good reasoning. So you're saying this is true, so this must be true. Good if then logic. And so students who are so scarred by elementary school, like, if I don't do it the right way, I'm wrong, will look at GED problems where they're reasoning problems and just stop. I don't remember how to do this. And just stop. And we really have to be able to call on those, well, what do I do when I don't know what to do? Can I do something? What can I do? And that's the kind of skills we're building right now. They're so important. Cool. So what is this? What is this? Oh, data analysis unit. This is a frequency focused chart and graph, just basically interpreting graphs. So here we go. Deep Discount Taxi Company charges a $3.50 or $3.50 flag drop fee, then a fee of 75 cents per mile. To the nearest tenth of a mile, what is the furthest a rider could travel with $20? Okay, what are they asking me to do or to find?
How far can someone go with this taxi company with $20 to the 10th of a mile?
Cool. Any thoughts?
It says right there, it's just a one-time $3.50 fee.
Interesting, because it doesn't say one time. How did you know that was a one-time fee?
Because it said like a flag drop fee.
Yeah, again, with word problems and being a little culturally biased, you have to know that a flag drop fee is how much you get charged for just sitting in the taxi. So the second you sit down in the taxi, boom, they charge you that $3.50 right off the bat. That's that one-time fee just to get in. Okay, wonderful. So what were you thinking to do with that sucker?
So I would just start writing it out, $3.50 plus, and then the per mile. So it would be 75 cents. And then it would be divided by question mark, I guess. This scare me because I...
Oh, but they scare... Okay, you got a lot of good reasoning going on. Yeah, the $3.50 is happening once. The 75 cents is per. And you really have to make a decision if you want to deal with this arithmetically or algebraically, because you could go both ways. The way you were starting looked like you were really doing algebraically to me. Like a $3.50 flag fee plus 75 cents per mile would total up to $20. Yeah, that's totally one way I could do it. It's not actually the way we did it when we encountered this last time, but it is good algebraic reasoning and it would work. You could use an algebraic equation to solve this. I'm actually going to come back to this because this isn't the way most students would do it, but I just want to show everybody that Amy would get the same answer if she did this. Did anybody else have any other thoughts about how to tackle this problem?
I would just write down the flag drop fee, that's one-time fee. And then I would just multiply 75 cents until I get close to the $20.
Oh, that's cool.
Maybe multiply it or just write it down. That's why I said it's probably long if you
No, I love it. It makes sense. I'm going to build on that. But let me deal with what you were saying about the flag drop fee first. Can we pay the flag drop fee, guys? Because you're right. The second we sit in that limo or that taxi, we got to pay the flag drop fee, right?
Yeah, so and then you have $16.50.
Beautiful. How'd you get that number? What operation did you use?
I minused.
Amy said I'd take the $20 and I'd take out the $3.50 I spent on the flag drop fee. I'd subtract it. And then I'd have $16.50 left to work with. Now, I love what Stephen's saying because it so applies to our last problem, whether we realized it or not. Because Stephen is now saying he would just repeatedly take out the 75 cents, one after the other, to figure out how many times that was. But Alicia told us we could use some algebraic reasoning. If we don't know how many times, we can use the opposite operation. What was the opposite of how many times?
Division.
Division. Beautiful. So, Stephen, what you're doing is the procedure to figure out how many times, whether you realize it or not, you are doing division. We could divide by that 75 cents per mile. And then our calculator would do that work for us instead of you having to go 75 cents and take out another 75 cents and take out another 75 cents. See, that's how many times. That's division. So 1650. And again, everybody would have gotten the right answer, okay? It would have taken Stephen a little bit longer, but he's being very visual as he imagines it that way. And
So
I get this.
Right, it was a long way.
Yeah, but it works. So that's what I'm saying. Good reasoning works. So I don't need you to memorize Kate's way. Okay.
I think Amy's example was easier. I didn't think of it that way, but when I looked at it, it makes sense. I guess our brains work different. So
yeah, but I want to show you how even though on the left we wrote about it very different than the right, it's the exact same math. Because look at this equation that Amy wrote on the left. If I wanted to solve something like this, you know, I say $3.50 plus 75 cents a mile should give me $20. If I wanted to solve something like this to work to get M alone, the first thing I would do is subtract away the $3.50, right? We move anything adding or subtracting first when we're solving. Well, what's the first thing you guys did? You didn't write about it algebraically, but the first thing you did was subtract away the 350. And then look at what we get. 0.075 M is equal to 1650. Now, if I wanted this M to be alone, I would have to get rid of that 0.75, wouldn't I? How would I isolate the M here? How would I get rid of this 0.75? Well, I'd have to divide. So I might have been writing about it differently, but the two steps that it takes in the end, whether I'm thinking about it arithmetically, using my common sense, or algebraically by writing equations, I'm still going to subtract and divide. Does that make sense?
Yeah, the way that I was taught in the classes that I took local was to go the algebraic way.
Mm-hmm. And that's why this is included on the GED, because this is a skill of writing and solving linear equations. Whether you guys are to realize it or not, this, if I were to draw this little sucker on a graph, the taxi fee looks like a line. And so that's why this very typical word problem always comes up on the GED. It's the simplest thing that comes up, and students don't understand why it's included with all this other hard stuff on the GED. And that's because one of the ways to do this is using algebra, but you don't have to. You don't have to.
I think Stevens is easier.
Yeah, Stevens is the easy.
Way easier.
Stevens is the most intuitive way to think about it. Anybody could do it. No matter if they were bad at math, they could take the coins in their pocket and give 75 cents for the first mile, and 75 cents for the second mile, and 75 cents for the third mile, and just be counting the miles as they go. I mean, it's so intuitive. And so I think it's a really beautiful way that any student could grasp it. And then they'd be able to pay that 75 cents 22 times, and they'd run out of money, and they'd have to get out of the cab. And by the way, this is really why I like doing classes with real students in it. You guys might be like, why does she do this? Why doesn't she just tell us how to go? Because the way I think about doing it, I'm super fluent in the language of algebra, is not the way that you guys are going to think of doing it. And it's you taking the test, not me. I like real students. So this is interpreting word problems. If you do it the way we did on the right, the basic operations. If you do it on the way we did on the left, is part of slopes and functions and lines, and it is writing linear equations.
Would this be calculator or no?
Everything that's algebra, geometry, interpreting word problems, data analysis, all that stuff is all on the calculator section. So yeah, you'd have one. So Denzel is looking for a location to open a coffee cart in order to expand his business. His realtor sends him a table to compare some statistics of his 4 favorite locations in order to make the final decision. Order the locations from least expensive in dollars per square foot to most expensive. All right, guys, what are they asking me to do or to find?
We want you to order the locations from least expensive in dollars per square foot to the most expensive.
Beautiful. Any thoughts?
The per square foot is what's throwing me off.
Bingo, Amy. I'm so glad you focused on that. If I didn't notice the per square foot, I would just start ordering these numbers right now. Okay, look, least expensive, then this guy, this guy, this guy. But it doesn't say least expensive in rental cost. It says least expensive in dollars per square foot. We have got to figure out the dollars per square foot in order to order these. So any thoughts?
How many square foot each location is?
Okay, so we don't currently know the square foot of each location, but we have some information to find that. Does anybody remember what square foot signals us to find? What does square feet mean? What are we finding there?
Like how many squares?
Yep, how many squares?
Is that like the covering? I don't know.
It is a covering, yes. Square feet, we're looking to cover the floor of the property in this case, yes. Square foot is area. We're talking about the area there. Okay, so let's look at the Fenley Mall location. How many square feet is the Fenley Mall location?
8 by 10.
It's an 8 by 10, 8 feet by 10 feet. So how many square feet would that be?
So you just, I guess, multiply
You
or
sure
use the
do.
formula.
Yeah, we can assume that these locations, because they didn't tell us otherwise, are rectangles. We could just multiply. And that's on the GED formula sheet if you forget it. But yeah, real simple rectangle problem. You just multiply there. So that guy is $650 for 80 square feet. All right, so how much is that in dollars per square foot? Any thoughts?
I'm thinking 80 times 650.
Okay, so let's try it. 80 times 650. It costs $52,000 per square foot. Does that number make sense to you? Invert your operation then. What's the opposite of multiply?
Divide.
Divide. The word per means divide. When you say dollars per square foot, and we even abbreviate the word per with a fraction bar, a slash, that means take the dollars, in this case 650, and per divided by the square feet, in this case 80. Beautiful. So 650 divided by 80, and it looks like that guy is costing us, I get this number.
8.125.
125. How much is it costing in dollars per square foot?
$8.
Yeah, $8 and like 12 cents, a little more than 12 cents. Yeah, nice. Okay, cool. Now let's look at that courthouse plaza, you guys. How could I figure out it's dollars per square foot? Again, I'm just going to keep writing it down to slam it home for you guys. Dollars per square foot means take the dollars and divide by the square feet. So I know the dollars, it's 790, but I need to per it divided by the square feet. How many square feet is that location?
110.
110. 10 times 11 feet is 110 square feet. I'll divide by 110 this time. Ooh, that's gross. I'll go around it. It's about $7.18 per square foot. Okay, what shall I do for Plinkton Park to figure out the dollars per square feet?
77.
Okay, so I'm going to be dividing by 77 because 7 times 11 feet is 77 square feet. And what am I going to divide by 77? I'm going to divide the number 580 by 77 square feet. 7.53. Okay, and now how about the entertainment district? How can I figure out its dollars per square foot?
9 times 9.
Is the square feet. Okay, so that's 81. So I'll divide by 81 square feet. And what am I dividing by 81? The $600 rental cost. So that one's about $741 per square foot. Okie dokie, guys. So now we got all the dollars per square foot numbers. Now we can order them from least expensive to most expensive. Which one is the least expensive?
Courthouse plaza.
Yeah, the courthouse plaza. Didn't look like it until we computed it down to what we call a unit rate. The blank per blank is the unit rate. Okay, so courthouse plaza is the cheapest. Okay, then the next
Entertainment district.
entertainment district. Next would come Plinkton Park. Dear Lord, when Kate makes up the names. And then finally, the mall is the most expensive location, which is probably why malls are closing all over.
I know.
Okay. Ooh, rude. So what's going on in that problem?
I'm not going to lie, I was overwhelmed when I saw that.
Okay, well, this is what I want to say to you. First of all, this is the GED. They love, 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 love real life applications of unit rate problems. This is a real life application of unit rates, reading a table, interpreting word problems, and area all in one place. They're like, woohoo, let's test them on everything all at once. So no wonder you were challenged. But the second I saw dollars per square foot, I cheered. So I'm just going to clear this. And I really want you to hone in. these are called unit rate problems. And the second you see that, you should go, I know exactly what to do. That tells me exactly what to do. You literally can directly translate it. Dollars, start with the dollars, per, divide by the square feet. This literally says take the money and divide by the square feet. They told you what to do, but they did it in math language. Definitely you want to be a ninja on unit rates. Okay, so this is up on the crash course. So important to the GED. It's in the interpreting word problems unit, but it's just straight a whole lesson on just unit rate problems because they're so popular in the GED. They're all over it. And there's a reason why. It's because it's an application of slope, whether you guys realize it or not, but it's all over the GED. It's their favorite. Okay, you guys, find the simplified product of 2x minus y and x plus 4y. What are they asking me to do or to find?
Multiply.
Multiply. What in this problem told you they were asking me to multiply?
Product.
Absolutely. Product is the answer when you multiply. Beautiful. So they want us to multiply these two things. Okay, guys, how you write it is really going to determine what you do. If I wanted to say that I was going to multiply these two things, how would I write that?
Start with a parenthesis.
Thank you. Super important that you use parentheses so that the whole first grouping multiplies with the whole second grouping. If you are like Manal, you might not need the parentheses to know what to do. She has her steps memorized. But if you're one of us who really struggles to memorize those steps, which is most GED students, just having it written like this will often kick off, oh, I know what to do now. Whereas you didn't know what to do before it was written down. What would I do now that I have it written down?
We multiply 2x.
We're going to pass out that 2x. So when she multiplied the 2x, the first term in the first parentheses, by the x, the first term in the second parentheses, she got 2x squared. I love it. Then what did you do?
2x multiplied by 4y.
Absolutely. We keep on passing it out. Just like when we were multiplying back with those decimals earlier, multiplication passes out. Everything multiplies with everything else. So 2x times 4y, 2 times 4 is positive 8, and x times y is just xy.
I got a little rusty.
You're a little rusty on this?
I haven't done this in a while.
Yeah, so this is multiplying binomials. A lot of teachers will use the FOIL. You never heard me say this, but probably in your adult education classrooms, they call this foiling. Yeah, Amy's nodding. So I'm basically taking this first term in this first parentheses, 2x, and I'm passing it out. Multiplication passes out to every term in the second parentheses. So it's two separate acts of multiplication. Just like when you take two-digit numbers and multiply, you pass it out. First the 2 multiplies by the 7, then the 2 multiplies by the 1. Same basic idea. Okay, now what?
Multiply minus y.
Beautiful. Now I'll take the next term and pass it out. Gorgeous. So what do you get when you multiply negative y times x?
Minus xy.
Beautiful. Manal knows that when you're multiplying, you just write the letters in alphabetical order. Y times x is just xy. Okay. Beautiful. And now we'll do, finally finish passing this guy out. Negative y times positive 4y gives me?
Minus 4y squared.
Beautiful. Okay. Negative times a positive is a negative. There's only one number, 4, so there it is. And y times y is y squared. Beautiful. We use exponents to talk about repeated multiplication. The most common error students make is to forget about those little floating 2's, those little squares. But y
Kate,
times
what is
y.
this called?
This is called multiplying binomials. On the crash course, I say multiplying polynomials because I group it with other things, but the particular type of polynomial here is a binomial. So a lot of teachers will call it multiplying binomials. We're talking about the same thing, okay?
Okay.
Okay, it's in the algebra unit.
I have to practice with this.
Everybody does. It's a challenge, especially if you struggle with letters. So, am I done? No, there is still more math I can do. Even though I finished my multiplying, just like when we multiplied decimals back at the beginning of today, if there's anything that can combine, add, subtract, I need to do that at the end. So let's go ahead and look here. Is there anything that can combine?
The negative xy and the negative 4y squared.
It's actually the negative xy and the positive 8xy.
Oh, because there's 2 xy's in it.
Exactly. They have to have, the variable portion has to be identical for them to add and subtract. Just like when I was talking to you about multiplying decimals, I said we only add and subtract the same kinds of things. We can multiply anything, but we only add and subtract the same kinds of things. Same rules apply to algebra. We multiplied everything. Everybody multiplied by everybody. Very hippy-dippy free love. But when we go to add, subtract, only identical variable portions can combine. So positive 8xy, and then we have this minus xy. What do I get?
Positive 7x plus.
Beautiful. A lot of students wouldn't realize that. They would just drop the xy, but realize if it doesn't tell you how many xy's you have, you just have one of them. So I had 8 of them. I take away one of them. I now have 7 xy's left. Beautiful. There's no other x squared terms. That just drops. There's no other y squared terms. That just drops. And I'm done. This is as simple as it's going to get. Ooh, we were rusty. Manal's like, I love algebra. And the rest of us are like, I need practice. Okay, so this is in the crash course in the algebra unit now. And like I said, the lesson that I made on just this is called multiplying polynomials and factoring for the GED. And there's just tons of practice. And the beginning level practice is real simple where it's written out for you. And then in the advanced level practice, I have it like this, where it comes up in all these different applications on the GED so you don't panic. Okay, a certain carnival game involves tossing beanbags onto a giant checkered surface. The surface is divided into 144 equally sized colored squares. Landing a beanbag on one of the 10 blue squares wins a small prize. A beanbag on one of the 8 yellow squares wins a medium prize, and a bag on one of the 4 green squares a large prize. There are 2 red squares that can win players the grand prize, a life-sized stuffed gorilla. What is the chance that a beanbag thrown at random lands on a square and doesn't win a prize? Oh my dear Lord, way to get overwhelmed, I'm sure. But let's go straight to the question. What are they asking me to do or to find?
What is the chance that a beanbag?
What is the chance? Also called likelihood or probability. So we're looking for the chance, the probability that what happens with the beanbag?
That someone doesn't win.
That they don't win. You guys, I'm talking about probability, and we can see that our answers here are in fraction form. So I'm going to be writing some kind of a fraction. Do you guys remember how we said we would build the fraction when we were doing probability?
Like winning over total or something?
That's how I usually phrase it. That's not the formula, by the way. I forget how they say it and real teachers say it, but I'm a fake teacher. No. I say wins over total. So anything I'm looking for to happen is what goes on top. And then the bottom is the total possibilities, anything that could happen. Okay, so let's go looking for those numbers. Now, this is a little weird because I'm looking for the chance that we don't win a prize. So I just called that the wins. So that's a little confusing. But in this case, it's the doesn't win a prize out of the total squares. Okay, any thoughts?
We count them all. For example, the 10 blue.
Those 10 blues, any one of those would win you a prize. So same thing with the 8 yellow squares. Any one of those 8 yellow squares will win you a prize. Any one of the 4 greens will win you a prize. And any one of the 2 reds will win you a prize. Can we start with how many win you prizes? How many of these squares win you prizes?
Not 144, is it?
144 is the total squares.
Total squares, okay. Oh, so maybe do 144 minus...
24, absolutely. I'm going to minus 24. How come?
Well, I added up all the things.
Yeah. If you add up all of these, that's 24 squares. 10 blues plus the 8 yellows plus the 4 greens plus the 2 reds are 24 winning squares. 24 that will win you a prize, but we're looking for the ones that don't win you a prize. So absolutely, Alicia, you could subtract those out. 120 of them don't win a prize. That's the top of our fraction, 120, but out of how many?
144.
Beautiful, 120 out of 144. This is the probability that one of your beanbags is not going to win a prize. 120 losing squares out of 144 total squares. Beautiful, but oh crap, I don't see that answer there. Any thoughts?
You have to reduce.
I gotta reduce. Now you guys, you can reduce it by hand, but not everybody's good at it. So you can also reduce it in your TI. Okay, so you guys can go ahead and reduce it by hand if you'd like. I'm gonna do it in my TI by using the N over D button. So you just type 120, then you use N over D to get the fraction bar, then 144 and enter.
5, 6.
Absolutely. Yeah.
Ah, I just learned how to use the fraction bar.
If nothing else good came up today, I'm so glad. You know, I spent a lot of time in that Facebook group. That's where most of y'all met me anyway, or heard about me at first. And I cannot tell you how many students I'm like, they're like, it's fractions all over the GED. Focus on fractions, focus on fractions. And then all these students spend months focused on computing with fractions, and it's not that kind of fraction problem. So like, here's an example. It is fractions, but That's not the skill we were using. The calculator did the like computation skill for us. Yeah. So it's so nice to know how to do fractions on this calculator because we really needed to focus on this word problem. It was intense.
Right.
Just out of curiosity, just to show of hands, is there anybody who would have gone a different way?
I just did a mistake. 24 over 144.
And I started correcting you. It's because you think about this a way that most students don't, Manal. But Manal was working backwards. She said, I'll figure out the winning squares first. 24 out of 144. And yeah, we would get 1/6. But the problem is those are the winning squares. So then we would have to take that 1/6 away from the whole one. So a lot of students wouldn't be able to do it that way. But yeah, absolutely, Manal, that totally works. But I just don't like you guys to subtract with fractions because you all lose your ever flipping loving minds.
How about we have a calculator?
Yeah, no, oh, Amy's like, I got a calculator now, girl. I can add and subtract fractions all day long. All right. Is anybody mad at me? Probably, but we should move on anyway.
We're not mad at you.
Just math and the GED and life. Okay. Okay, this is from the data analysis unit. This is a probability problem, but it's pretty complex. We saw a lot of interpreting word problem skills in there. Okay, the shape to the right is composed of an equilateral triangle with a 7.6 centimeter side length and a 6.2 centimeter by 9.4 centimeter rectangle. What is the perimeter of the composite figure? All right, what are they asking me to do or to find?
The perimeter.
And the perimeter of what?
Composite figure.
Of the composite figure of the whole darn thing. Beautiful. Any thoughts?
The equilateral triangle is 7.6. So these two sides are 7.6 and 7.6.
Beautiful.
Okay, so the rectangle 6.2 by 9.4.
Beautiful. Which should I put where? Should I put the 6.2 here or here?
The length is 9.4.
Now I'm going to ask you to stop because Manal's like, easy. Everybody else is like, how'd she know that? Okay, guys, how do we know to put the 6.2 there and the 9.4 there?
Because the longer side obviously would be 9.4.
Oh, okay. So Amy was just looking at it visually. That side looks longer. Just to let you know, sometimes they're jerks and they aren't to scale. Sometimes they're jerks and they aren't to scale. So just because it looks longer doesn't necessarily mean it is. But I knew that it had to be the 6.2 over there because I know this total length is 7.6 and I needed the thing that was smaller. So cool, we got our measurements there. So that means that this side is also 6.2 and this side is also 9.4.
We didn't finish.
What didn't I finish?
Still we have these small sides, right?
Mm-hmm. We got these little weird pieces.
Yeah. So it's 7.6 minus 6.2.
Okay. I like that. Let's talk about why you chose. Oh, Alicia said, Alicia, explain why Manal wants to minus. Why does Manal want to minus?
Well, because that side equals 7.6. So, and then that little piece is 6.2. So that's how she got the answer.
Yeah, she said that whole length is 7.6. If I take out the 6.2 I don't want, that'll give me the other pieces. So wonderful. I get this number 1.4. Now I got to tell you what most students do. They do this. Okay, 1.4. 1.4. I just did something wrong. That was foolish. What'd I do?
Yeah, the total red is 1.4.
The total red, I like it, is 1.4. What would you like me to do next?
Divided by 2.
Oh, sure. I could divide it by 2. That means this piece is 0.7 and this piece is also 0.7.
Then we add the numbers.
Then we add what numbers?
The sides.
Yeah, tell me which numbers to use because some people add extra numbers.
Oh, 7.6. Plus 7.6, 0.7, 0.7, 9.4, 9.4, and 6.2.
Beautiful. So you only said 6.2 once. How come I'm not using this 6.2?
It's inside, not outside.
Thank you.
Because
perimeter is the distance around the outside of the shape. Don't be distracted by inner measurements. Beautiful. I love how Manal's just like, duh, Kate. Yeah, duh, maybe to you, Manal, but for the rest of us, we struggle. Okay, so don't use any of the inner dimensions when you go to find the perimeter of a composite shape. Did you guys get 41.6?
Yeah, I did.
Beautiful. Now, Manal divided it in half and used both those 0.7s. Amy said, I'll just use the 1.4 total. 0.7 and 0.7 give me 1.4. So I don't care which one you use, just use it the right number of times. Either use the 1.4 once or both the 0.7s. You'll get to the same place in the end. Gorgeous. Good math. Always works regardless of which reasoning you use. So 41.6 what, y'all?
Centimeters.
Centimeters?
Plain old regular linear centimeters. Perimeter is a line around the outside. Glorious. Hey, that one was not as hard as I thought I was going to make you guys cry. Nobody even cried, not even a little bit.
The volume and stuff like that, that's a
Make
little...
you cry? That's funny because to me, that's the easier one. Because the volume and surface area, I always have the formulas for. But these composite shapes, now I got to kick in. I actually have to know what area and perimeter mean with composite shapes. I can't just use the formula, especially perimeter. So you have to realize that perimeter is a distance around the outside. So it's one of the few times you can't just pick out a formula and blindly use your algebra skills. But that being said, everybody has different things they find challenging, you know. We all have different struggles. So this is from the geometry unit. This is perimeter of composite shapes. Got a ton of different examples on there, all different kinds of shapes. Okay. Luis has a website that sells custom t-shirts. Luis makes a $2,300 profit in a month where he sells 500 t-shirts. But if he sells 700 shirts, he makes 5,100 in profit. Oof, go Luis. If Luis were to graph his profits based on sales, what would be the slope of the resultant line? What are they asking me to do or to find?
The slope.
Good. So we're finding the slope of the resultant line. Problem is I don't have a line in front of me. I have some information about profit and t-shirts and shirts and profit. And what are your thoughts?
This is what the slope formula comes in.
Oh, I could use the slope formula. Wonderful. So if you hit up your GED formula sheet, the slope formula says this. Slope, M, is equal to the change in y, so y2 minus y1, over the change in x, so x2 minus x1. Now, a lot of students would look at that formula and be real intimidated, not even sure what to do with it. Any thoughts about that?
You have to find the y and the x.
Yeah, I need to, if this slope formula uses points. So if I want to use this formula, it would be really good to look at these two things I'm looking at, these relationships here, as points on a graph. Okay, so if I were to look at these as points on a graph, let's look at the first relationship. Luis makes $2,300 profit in a month where he sells 500 t-shirts. Let's make that information into a point. Yeah, the independent variable, the x, is the t-shirts.
2,300, so depends on the 500s.
Beautiful. So the $2,300 is the y because it depends on how many t-shirts he makes. Yes, this is your dependent variable. It depends on his sales.
Because we're saying dollars per t-shirt.
Yes, it's like dollars
Per something.
per t-shirt. Yes, the slope here, if in a real world way, would represent the unit rate of dollars per t-shirt. Nice. So I want the dollars as my y's and the t-shirts as my x's. Beautiful. So when he sells 500, he makes $2,300. When he sells 700, he makes a lot of money and he's going to take me out to dinner. He makes $5,100. Okay, sweet. Let's plug these numbers in now that we know that. Stephen says I want the dollars on top. So let's find the change in dollars. Okay, the second dollar amount he makes is $5,100. That's what Y2 just means, the Y from the second point. And then we're going to take away the Y from the first point, so the $2,300. Okay, that's the amount of dollars his sales changed by. And then Stephen said that's per t-shirt, so let's find the change in t-shirts under there. So my X2, my second number of t-shirts was 700, and I'm going to subtract out that. The X1, the first number of t-shirts, that was 500. Now you can have it memorized, change in dependent variable over change in independent variable, or you can use the formula, but you still have to know which one would go on the top and which one would go on the bottom. So I like what Stephen said about dollars per t-shirts. All right, now let's simplify this. Let's do our subtraction first. 5,100 minus 2,300. I'm doing my subtraction first because tops and bottoms of fractions make groupings. So that's a $2,800 change for selling how many more shirts? 200 more shirts. So what's the slope then of this graph? Yeah, 2,800 divided by 200 gives me 14. And I love the way Stephen interpreted. He's making $14 per t-shirt. Every time that dude sells another t-shirt, that's another 14 bucks of profit in his pocket.
He taught me this because I saw one of the slope videos, so that's how I remember.
Yes. I am so impressed, Stephen, because even students who are good with slope often struggle when it hits word problem. So really good job of using your reasoning skills to figure out which one went on the top and which one went on the bottom. That's the thing about you, Stephen. Like I said, you're a real practical guy. As soon as you have a real life application of it, it trumps your struggle with the symbols. So that's good. That's a really good ability to fall back on because not everybody has that strong common sense. Definitely, if you've not done this before, this would be something to practice. So this is in the slope and lines unit, and this is slope as a rate of change. You want that skill that Stephen has where you go, oh, slope, that means something per something. That ability will really help you get those numbers in the right order. Oh gosh, does that look like the GED or what? Nobody vomit. We can do this. Solve the inequality for R. Okay, guys, what are they asking me to do or to find?
Solve for R.
Solve for R.
Like you do in an equation, I guess.
Yes, just like you do an equation. They're asking us to isolate R, or get R by itself, figure out what R would have to be in order to make this sucker true. Gorgeous. Okay, well, this looks like a doozy of a nasty thing to solve. Any thoughts?
We divide 4 by 20, we'll get 5, and then we multiply by 3.
Oh, I see what you're doing. Okay, so let me just explain to everybody what Manal's doing right now. Manal is seeing that this negative 3/4 is shoved up against the parentheses right there. It's multiplying, okay? And so we can do that multiplication. We can pass out this negative 3/4 times these two numbers. And that is a great general rule. If there's any simplifying you can do on either the left or the right-hand side, then you go ahead and do it. Now, Manal, not everybody would do that by hand. That's what Manal was doing, multiplying fractions by hand. You can also do it in your calculator, okay? So don't be scared if you're not like Manal, who's got it memorized how to multiply fractions. Okie dokie. But let's start with the first one, just because I like to work left to right. What is negative 3/4 times 8R? You can use that fraction bar in your calculator to do negative 3/4 times 8. So let's do it together. So you typed your negative, and then you put in your little fraction bar and did 3/4. But right now you're blinking on the bottom of your fraction. See how your cursor is down there in the bottom of your fraction? You need to get out of your fraction by pressing right arrow. Now you can go times 8. You might have also used a times button.
I didn't use mine still got the same answer though.
Yeah, as long as you got -6, you're fine. There's not one right way to do it, Stephen. You see Manal's doing it by knowing what it means to do fractions. She's dividing by 4 and multiplying by 3. It means the same thing, right? So, you know, it's not like there's one right way to do it, but you better be getting -6 or we're having a calculator error or a logic error one way or the other. Let me just synopsis because now my screen is deleted. Okay, so we were solving this inequality for R. We're working to isolate R. Beautiful. First thing we were doing was doing some simplifying on the left-hand side, passing out that negative 3/4. So negative 3/4 times 8R, whether you do it in your calculator or by hand, is going to give you -6R. Cool. So now practice this. Try doing, Alicia, negative 3/4 times -20. Make sure it's times -20 or you're going to end up subtracting by accident. Manal's so lovely. She knows how to do it by hand. She says if I divide by 4 and then just multiply by the top, 3 times 5 is 15. So that's what you guys should get out of your calculator, even if you're not good at doing fractions by hand. And by the way, students are so scared of fractions, they think it's going to be hard to multiply and divide them because it's hard to add and subtract them. It is so easy to multiply and divide by fractions. That's really why Manal's sitting here going, why are you guys using the calculator? But you can still do it in your calculator, even if you don't know that, right? Okay, so we passed that sucker out. Now we should drop down anything we haven't used. We haven't used the 5. Okay. How about the right-hand side? Is there any simplifying we can do over there?
No.
No, so I just drop it down. Cool. So I did some simplifying on the left. Any thoughts? What shall I do now?
We add 5 plus 15.
Beautiful. Manal sees that there's more simplifying I can do on the left. There are some like terms I can combine. Plain old regular numbers are like, they will always be able to combine. And 5 plus 15 is 20 or positive 20. Beautiful. Now there's nothing like with the R, so it'll just drop down and I'll drop everything down. I have finished my first step here of simplifying the left and right hand side. Cool. Any thoughts? What now?
You want to move your variable term on the right.
Beautiful. I want to get the variable terms together. Gorgeous. And I like taking the one from the right too, Stephen, and moving to the left whenever I'm doing inequalities. So I will take the one on the right, move it to the left by using the opposite operation. The opposite of subtracting 3R is adding 3R. And I will do it to both sides because it's a change I'm making. Beautiful. Next step after we simplify should be to get the variable terms to the same side. Cool. Let's see what my new inequality will be here. Negative 6r plus 3r. Again, you can use your calculator to deal with the negatives, but you need to know that negative 6 plus 3 gives me, if you typed into your calculator, negative 6 plus 3, it's negative 3. It's like I owe you $6, I give you 3, I start paying down my debt. Now, I haven't done anything to the 20, and that's going to be less than or equal to the 14. The 3r is now gone from that side. Okay, now what?
We take the 20 on the other side.
Beautiful. We are going to start working to isolate the variable. And you can tell who learned from me and who didn't, because Stephen knows how to say it the way I'd say it word for word, but Manal just knows what to do, but same difference, okay? We're going to move that 20 over so r can be alone. So yes, we'll use it the opposite. We'll subtract 20 from both sides. 14 minus 20 is negative 6. Then on the left-hand side, I have negative 3r. Now we have to talk inequality symbols, because when you start moving around numbers, sometimes they flip and sometimes they don't. So what should my inequality symbol be? Is it the same or did it change?
It to be the same?
It is the same. Nothing happens when you add and subtract. It'll never get affected by adding or subtracting. And our inequality symbol is only ever affected when we multiply or divide by a negative. Beautiful. Okay, so there's my new inequality. Negative 3r is less than or equal to negative 6. Now what?
We divide.
We will divide. Thank you. I'm so glad Manal said divide. Most students want to add 3, but it's not adding because that 3 is not subtracting with r. That 3 right now is all shoved up against r. It is multiplying. We will do the opposite of multiplying. We will divide away negative 3, and we will do it to both sides. So the opposite of multiplying by negative 3 is dividing by negative 3. They cancel r's alone like I wanted. And there, that is negative 6 divided by, ooh, I tried to screw something up. On the left-hand side.
The symbol, because we did division.
Thank you, Amy. Amy caught me. We just divided by a negative number. Fired, Kate. You are totally fired. That's the one thing you're supposed to remember that's different about inequalities. If you multiply or divide by a negative number, your inequality symbol will flip. I won't have less than or equal to anymore. I will have greater than or equal to positive 2. And you better believe less than or equal will be in the answers, because they know you guys forget that, just like I tried to forget that, even though I do math 10 hours a day. That's sad. For anybody who's worried about that, this is the main takeaway you need to make with inequalities. If you multiply or divide by a negative, you must flip your inequality sign. You have negated, I call it negated, the inequality. And this is one of those things that just doesn't necessarily make a lot of sense to students, which means you're going to be prone to forget it. So keep it in your notes, highlight it, star it, practice with inequalities a lot so you get in that habit. And check your work at the end. When you go back and you have a few minutes left on your GED, go back and check, did I have any negatives on inequalities I forgot to flip? So this is the algebra unit. The topic is solving inequalities. Guys, I have everything from the very simplest of one-step inequalities up to these ugly things with fractions and stuff. The GED loves to combine fractions and inequalities. I think because they know that most students will just panic and just shut down right there. I don't know how to do fractions. No, Manal knew how to do fractions. She did them by hand. The rest of us didn't. We did them in our calculator, and we were still able to deal with the inequality. So don't let it be the fraction that stops you.
Once you get rid of the fraction, it makes it easier to solve.
Mm-hmm. And the day you got equations and inequalities, you got the power to get rid of fractions. You can literally get rid of any fraction you see instead of dealing with it. Because we have the power to do whatever we want to both sides. So I just do math that gets rid of the fraction to both sides, even on things much more complex than this. Way down in complicated math I did in my college class, the very first thing I do when I had an equation or an inequality was get rid of the fraction. Because there's so many chances for errors when we're doing computations with fractions. It's a beautiful power to have if you know you have it. Well, yay, we're done. You guys did hard stuff. Is this how you feel? You feel like this poor little puppy right here? But I just want to say something to you guys, and that is this. If you are watching this video and you are so intimidated right now, like there were 2 or 3 problems that you just say, those were above my head. There is no way. I just need to remind you, when you go to take the GED, you have to get less than half right to pass. So there were 2 or 3 where the wording just teed the crap out of Manal. There were 2 or 3 where the symbols were frustrating Stephen. You know, there were 2 or 3 where the algebra was just a little too deep for Alicia. We all have our struggles, but I don't need you to be good at everything. So drop that burden off your shoulders. But what you are good at, you need to be really good at paying attention to detail, because all of these problems, regardless of what subject they were complex. There was a lot going on. We had to be good organizers. We had to not get tricked by wordplay. So don't worry about being good at everything, but do worry about just taking what you do know to a really high level of understanding. And that's how you're going to pass the GED.
So I want to take a minute to thank some people. Just to let you know, these videos here have been a labor of love. I started the Math 144 series back in the summer of 2020, and it is now spring of 2022, and I am editing the 7th video here, about to put it out of 8. And so at the end of 2020, I quit my real job, the one I get paid for, in order to finish these giant projects that I'd had on the table for so long that I hadn't been able to finish, like this one, like the Math 144 videos. I'd been able to start them while working full time, but not finish them. And so I wanted to do so much and needed more time. And so many people have been blessing me and supporting me since I did that, in order that I could do things like this for you guys, that I could provide free practice tests that are just geared not to maybe the students who usually watch math videos, but those struggling students who really need the extra help. This is who this is for. So all of these people have been faithfully supporting me to make sure that I can do what I do to benefit you. So I want to thank them. You should take a moment to thank them, whether it's in the comments or by shooting me an email. And my supporters would love to know that. But first of all, we have my patrons who support me monthly. The light and salt level is $15 a month. Big commitment for a lot of people. So I'm just so thankful for those who are able to do that. I also want to thank those who are at the sprinkle salt tier, giving $9 per month to Light and Salt Learning. And of course, my Shine a Little Light crew. This is where most of my students come in. I think $3 a month, and you can pay it forward to make sure other GED students have the same resources that you had available to you. I am just so thankful for the cups of coffee you've gotten me. So my Buy Me a Coffee page, you can donate $5 at a time, and they call it Buying Me a Coffee. I'm so appreciative. Over the last year, these are all the people who've bought me sometimes more than one cup of coffee and just kept me encouraged and blessed. And I just want to say to all of you who support Light and Salt Learning, thank you, because you're just as important as I am in this process. You know, you are enabling GED students across the world, and we really are across the world. I think at last count, 153 countries using the GED Math Crash Course in order to prepare for their GED. So you are enabling GED students across the world to meet their goals. Thank you so much.